All right, we're back and we're going to work on more identities. How exciting. Example 1 says, use addition formulas to write cosine of 2x as an identity in 3 different ways. Now, if you don't remember from last time, cosine of alpha plus beta is equal to cosine, cosine, sine, sine. So cosine of alpha times cosine of beta with the opposite sign minus sine of alpha times sine of beta. Now, in this case, if we're finding cosine of 2x, what we can do is we can say cosine of 2x is the same thing as cosine of x plus x. And now our angles alpha and beta are just happen to be the same angle. So then we would write this as cosine of x times cosine of x minus sine of x times sine of x. And if we simplify that, that just becomes cosine squared x minus sine squared x, which is equal to, I should have started off saying that this is the left-hand side and this is the right-hand side. And so we are done there. Part B wants us to prove that cosine of 2x is equal to 1 minus 2 sine squared of x. Now, I'm going to start off with the left-hand side with cosine of 2x, and I'm going to skip a little bit because I've already done this in the previous step. So we know that cosine of 2x is equal to cosine squared x minus sine squared x. And we're trying to get it so that our new expression that we're dealing with only is in terms of sine. And so I'm going to come off to the side here. And I know the Pythagorean identity is sine squared x plus cosine squared x is equal to 1. And so if I manipulate this identity to solve for the cosine squared portion, then we find that cosine squared x is equal to 1 minus sine squared x. And so now I can substitute this expression in for cosine here. So then I'm going to rewrite this as 1 minus sine squared x minus sine squared x. And then that becomes, through algebra, 1 minus 2 sine squared x, which is equal to the right-hand side. And so I am done there. And then part C wants us to prove that cosine of 2x is equal to 2 times cosine squared x minus 1. So I'm going to start off with the left-hand side. And I know that cosine of 2x, again, based on part A, is equal to cosine squared x minus sine squared x. And this time, we are trying to get it so that it only contains cosine. And so if I come back up here and I solve this identity for sine squared x, we get that sine squared x is equal to 1 minus cosine squared x. And so now I can replace sine squared x with this thing because of the Pythagorean identity. So we get cosine squared x minus, now be careful here, I want to put brackets or parentheses because I'm subtracting off this entire quantity. This is where students will often get messed up because of the algebra. Now this becomes cosine squared x, and if I distribute that negative sign in, we get minus 1 plus cosine squared x, and then through some algebra here, we can combine this to say 2 cosine squared x minus 1, which that is equal to the right-hand side. So I'm going to put my little proof symbol to indicate that we are done with this example. Example 2 wants us to find a formula for sine of 2x using the addition formulas. So we're basically going to do the same thing that we did in example 1, except now we're going to do it for sine. And if you remember from the previous unit, sine of alpha plus beta is equal to sine, cosine, cosine, sine. And because it starts with s, we have same sign, so sine of alpha times cosine of beta plus sine, No, that's not right. Sine, cosine, cosine, sine. So cosine of alpha times sine of beta. All right, so now we're going to do the same thing. I'm going to start off with sine of 2x, and I can rewrite that as sine of x plus x. And so if we follow the formula from up above, we get sine of x cosine of x plus sine of x times cosine of x. And if both of those are like terms, if we combine them, we get 2 sine x cosine x. Okay. Example 3, find a formula for tangent of 2x using the addition formula. So basically same thing what we've been doing. I'm taking tangent of 2x and I'm rewriting that as tangent of x plus x. And if you plug that into the tangent sum formula, we get tangent of x plus tangent of x over 1 minus tangent of x times tangent of x. And so if we simplify that, we end up getting 2 tangent of x over 1 minus tangent squared x. So that was the derivation for all of what we call the double angle formulas. And I don't know that I necessarily memorize these. It would be helpful if you memorize them, but my memory is really bad. And so I will often have to derive these just like we did above instead of me memorizing them. Do what works for you. If you have these down and memorized, it's going to make doing these trig identity proofs a lot easier for you. So you don't have to constantly derive it every time, but find what works for you as you work through these problems. But I definitely recommend that you memorize the sum and difference formulas at the minimum.